Assalamu alaikum everyone. So let's recall that previously we've learned the exponential function and even we've learned how to graph it. In today's lesson, which is 8.1, we will learn the logarithms and the logarithmic function. So first, we will learn how to evaluate the logarithmic expressions, and then we will graph these logarithmic functions. Okay, let's start. So the logarithm with base b. So let's say we have b and x to be positive numbers, where b cannot be equal to 1. The logarithm of x with base b is denoted as shown here and is defined as the exponent y that makes the equation b to the y equal x true. Now, suppose that b greater than 0 and b is not equal to 1. So for x greater than 0, there is a number y such that this is true. So log bx equal y if and only if b to the y equal x. In other words, there is a relation between the logarithm or the logarithmic function and the exponential function. And this is how they are related. So this is the inverse of the exponential function. And this is the logarithmic function. And first, we will learn or we will evaluate the logarithmic function by changing the form of the function given. So if I gave you an exponential function, you will have to write it into a logarithmic function. And if I gave you a logarithmic function, you will write it into an exponential function. This is an example. So if log 327 equal y. So we know here that the y, that the 3 is the base. And the 27 is my x. So I can rewrite this, which is this, in terms of this. So if I want to change the form of the logarithmic function into an exponential function, it will be as follows. 3 to the y equal 27. Okay, let's see our first example. So we want to write log 39 equal 2 in the exponential form. So to write this into the exponential form, you will have to remember this relation. So by remembering that relation, we know that to change this, we will write it in terms of x equal b to the power of the y, where here 9 is your x, b is your 3, and y is your 2. So this is the answer in terms of the exponential form. This is another example, and we want to write it into the exponential form. Again, it will be the exact same thing. So it will be x equal b to the power of the y. So it will be 1 over 100 equal 10 to the power minus 2. And 1 over 100 equal 10 to the power minus 2 is my answer, is the exponential form. This is another example. So using the same technique we've talked about earlier, we can figure out and know that the answer will be 2 to the 3 equal 8 here, which is B. Moving on to the second example. So in the first example, we've learned how to write the logarithmic form into an exponential form. In example 2, we will do the opposite. We will write the exponential form in the logarithmic form. And we will use the same technique. So we know that this exponential form, here 5 is my b, 3 is my y, and 125 is my x. So to change this into a logarithmic form, we know that we have to write it in terms of y equal log bx, which will be as follows. So log b and x is my 125 equal y. And this is my answer. Again, this is another example where we will write it in terms of the logarithmic form, and we will use the same technique. It will be log b, and here b is my 27, equal x, which is 3, equal 1 over 3, which is my y. This is my answer. And here again, there is another example where we need to write it in terms of the logarithmic form. And by applying the same technique we've discussed in the previous two examples, we will see and find out that our answer is D. Okay, so now we've learned how to change the form of the equation. So I can write the logarithmic form in terms of an exponential form and the exponential form in terms of logarithmic form. So now I need to evaluate my logarithmic function or my logarithmic expressions. So I have this logarithmic expression, log 3, 2, 4, 3. So my first step to evaluate it is we need to let the logarithm equal y. So I need to write this expression equal to y. Sorry. Then we need to use the definition of the logarithm. So I need to change this logarithm into the exponential form. And we know to write the exponential form, it is x equal b to the y, which will give me 243 equal 3 to the y. Next, I need to write both of them in terms of the same base. If you remember in the previous lessons, when we discussed the exponential function and we evaluated them or we solved them, one of the most important steps, which is the first step, is to have the same base. So here, to be able to solve this and find the value of y, I need to make both of these has the same base. So I can write 243 in terms of 3, which is 3 to the power of 5. Okay, we wrote them. And now once I have the same base, I can just equate the exponents. So using the property of equality for exponential functions, I equated them and I got my y to be equal to 5. So my answer finally is log 3, 243 equal 5, after you found that this is your y. Another example. So here I need now to evaluate log 10, 1000. You will do the same exact steps, which is, first step, you will equate this expression to y. Then you will change it into exponential function. You will equate, or you will make your base to be equal in both sides. And finally, you will find the value of y. Doing that, you will get your y equal 3, which is your answer. Okay, moving on. Now, here, this is the parent function of the logarithmic functions. So this is the parent graph. So f of x equal log b to the x, log bx. If b is greater than 1, this is how my graph will look like. And if b between 0 and 1, this is how my graph will look like. My intercept is 1 and 0 in both of them. My domain is x greater than 0. So you can notice that I don't have anything in this side. I don't have a graph in the negative side. So my domain only the positive real numbers in both of them. And the range is all real numbers. Okay, so here in this example, we will learn how to graph the function f of x equal log 3x. So step number 1, we need to identify the base. You need to know what's your base, what's your b. Here b is 3. So you know that here b is greater than 1. Okay. Now, second step, we need to determine points on the graph. So whenever you want to graph your logarithmic functions, there is 3 important points that we will be using whenever we have to graph any logarithmic function. The points are 1 over b and -1, 1 and 0, and b and 1. So you will replace hb with your 3. Doing that, you will have the points 1 over 3 and -1, 1 and 0 stays as it is, and finally 3 and 1. All what you need now to do is plug these points in your graph, and finally just connect the points. You will end up with this graph. And you already know that it will look like something like this because you know the parent function for the logarithmic function. You know how the parent function look like. Next. Now we need to graph f of x equal log 1 over 4 and x. Here, my b, you can notice that the b is 1 over 4, which is between 0 and 1. Again, you will use exactly the same points. So, previously, I had the first point 1 over b and -1, right? If you put now your b to be 1 over 4, you will end up with 4 and -1. And 1 and 0 as it is. And last, you have b and 1. And your b is 1 over 4. So now these are my new points. Again, you will just put the points on the graph, connect them, you will end up with this graph. Here, another example. We already know the parent function for the logarithm, right? And you can see that your b is greater than 1. So, by this information, and since we know that the parent function has an intercept at 1, 0, so automatically I exclude a and c. So I'm left with b and d. Okay, and we know that my answer will be one of these. And since we know the parent function, you can easily know that it is d. Again, this is another example, but now for the b, it's between 0 and 1. Again, based on the information that you know, the answer will be A. Okay, after learning how to graph the logarithmic function, we know the parent function. Now we need to know how to apply the transformation for this function. So f of x equal a log b, x minus h plus k. So h for the horizontal translation. If h is positive, then I go h units right. If h is negative, I go h units left. K has to do with the vertical translation. If K is positive, I go K unit up. If K is negative, I go K units down. And A, if A is negative, then I have a reflection across the x-axis. And if the absolute of A is greater than 1, then the graph is stretched vertically. And if the absolute of A is between 0 and 1, then the graph is compressed vertically. Okay. So we need now to graph this logarithmic function with these transformations. So the first step is to write what's your b. First of all, you want to know, is your b greater than 1 or is it between 0 and 1? Second, make an analysis about the transformation you have. So here I have k, which is -1, which means I'm going 1 unit down. I also have my a to be positive, and it's between 0 and 1, which means it is compressed vertically. As I said, absolute of a is 1 over 3, which is compressed vertically. I don't have a horizontal shift, so h is 0, k is -1. And here is your graph. To know how you graphed this one, you will use exactly the 3 points we've discussed earlier, which is 1 over b, 1, and 1, 0. And finally, b and 1. Sorry, at the beginning, it's 1 over b and minus 1. So for these points, let's go back here. So we said our first point is 1 over b and minus 1, right? Okay. We have to apply the transformation on this point. So you will apply the transformation on every single point of them. So I don't have a horizontal shift. I only have a vertical shift and a vertical compression, which means my x values are not changing. I don't have anything that is affecting my x values. However, I have things that is affecting my y values. So in my first point, which is 1 over b and 1 and minus 1, sorry, I have the a and the k is affecting my minus 1. So, and remember, please, you always multiply by the a and you add the k. So the minus 1, you will do minus 1 multiplied by 1 over 3. You will get minus 1 over 3, and then you will add to it the minus 1. You will end up with a new point now, which is 1 over 3 and minus 1.3333. Okay. And you will do exactly the same thing for every single point. If you have, again, a horizontal shift, then you will add the horizontal shift for the x values in your 3 points. You will end up with this graph. Again, this is another function that we need to graph. Here, I have a to b 4, which means it's greater than 1, so it's stretched vertically. Again, I have h to be negative 2, so I'm going 2 units to the left. And I don't have a k, so k is 0. Again, remember that you know the parent function. So you can always draw the parent function and then apply this transformation on it. So I can put the parent function and then move 2 units to the left. I can stretch the graph vertically, or you can use the points idea that I discussed in the previous example, where you will multiply always whenever you have a, k, and h. A and k affects my y, and h affect my x values. A, you multiply it by the y, and you always start with your a, and then you add the k if you have a k. And if you have the h, you just add it to the x values. And this is the graph. Okay, moving on to real world example, which is example 6. So at Earth's surface, the air pressure is defined as 1 atmosphere. Pressure decreases by about 20% for each mile of altitude. Atmospheric pressure can be modeled by P equals 0.8 to the x, where x measures altitude in miles. And we need to find the atmospheric pressure in atmospheres at an altitude of 8 miles. So first of all, they gave me the model. This is my original equation. Your first step is that you will write the inverse. So here, what you will do is you will substitute 8 for x, because they told you that the altitude is 8 miles. And they said that x measures the altitude. So here you'll substitute 8 instead of the x, and you'll find your atmospheric pressure. So my answer is 0.168 atmospheres. Part B. So now I need to write an equation for the inverse of the function. This is the original function. When you want to write the inverse of the function, you always replace the x with the p and solve for p. So I replace my x with b and then use the definition of the logarithm to write it in this form. So my answer is p equal log 0.8x. Next example. So the air pressure of a car tire is 44. The pressure decreases gradually by about 1% for each trip of 50 miles driving. The air pressure can be modeled by P equal 44 0.99 to the power of x, where x measures the number of 50-mile trips. Find the air pressure in pounds per square inch after driving 350 miles. So x is the number of 50-mile trips, and I want to know what happened after driving 350 miles. So first of all, to find the value of x, I need to divide the 350 with the 50. So 350 divided by 50, I will end up with 7. So x equals 7. You will take this 7 and put it here. Put 44 multiplied by 0.99 to the power of 7 in the calculator. You will end up with 41, which is your answer. Next, part B of the question. Now I need to write the equation for the inverse function. So I have this one, and I need to write it in terms of the inverse of the function. So first of all, I will divide here by 44. I will end up with P over 44 equal 0.99 to the power of x. So now I have it in terms of the exponential function, in terms of x equal b to the y. Now I will find the inverse of the function. How do we do that? Let's replace the p with the x and then use the definition of the logarithm. You will end up with d as your answer. Thank you so much.